Welcome to Lucky Learning, your favorite YouTube channel. Here in this video, I'm going to explain discrete mathematics mid-1 objective questions, which will be helpful for your preparation of the mid exam. And this objective questions consisting of multiple choice questions and fill in the blanks question. Look at the first question. The binary relation 1 1 2 1 2 2 2 3 2 4 3 1 3 2 on the set 1 2 3 is dash. So it is asking what is the property of the relation. Here you observe it is having 1 1 2 2 ordered pair but not 3 3 ordered pair. So it is not reflexive. Then we look for symmetric relation. It is 2 1 but we don't have 1 2 ordered pair, so it is not symmetric. But you look at, if it is 2 1 and 1 1, we can say 2 1 is an ordered pair according to transitivity rule. Look at 2 2 2 3, then we have an ordered pair 2 3. It is also there according to the transitivity rule. And same thing 3 1 1 1, you will get a 3 1 ordered pair, that is also there. Look at 2 3 and 3 2, because 3 3 same, then you will get an ordered pair 2 2, that is also there. Then this relation is satisfying transitivity property. Then the answer for the question is transitive. The second question, dash number of reflexive relations are there on a set of 11 distinct elements. Question is about how many number of reflexive relations. If there are n elements, the number of reflexive relations are 2 power n into n minus n. It is straightforward formula. Now, what is the value of n here? 11. So, the number of reflexive relations are 2 power 11 into 11 minus 11. 11 into 11, 121 minus 11, which is equals to 110, means the number of reflexive relations that are possible with n distinct elements are 2 power 100. The third question, the power set of empty set has exactly, what is the empty set? Pi. The power set of exactly uh, of empty set is having empty set. So means it is having zero subsets. Means there are no subsets. The power set of empty set has exactly zero subsets because empty set is pi. Pi does not have any subsets. Question 4. Let P. This is a great website. Q is a proposition. You should not come back here. Then there is a statement given. This is a great website and you should come back here. You should come back here. Now, this is a great website is a proposition P and you can write as a conjunction. And the second proposition, you should come back here. But what is given Q? You should not come back here. Here, what is you should come back here means it is a negation of Q. Then you can write this as a compound proposition P and negation Q. Fourth question. What is the converse of the conditional statement? What is a conditional statement? P implies Q. Its converse we can call negation Q implies negation P. Its inverse we can call, sorry, its coming to fifth question. What is the converse of the conditional statement? Conditional statement is P implies Q, and the converse of P implies Q is called Q implies P, and inverse of P implies Q is called negation P implies negation Q. And we know that contrapositive of P implies Q equal to negation Q implies negation P. These are important things to remember. P implies Q have a converse, Q implies P, inverse negation P implies negation Q, and contrapositive negation Q implies negation. What is asking? What is the converse is asking? Of the conditional statement, if it ices today, ices today is called P. I will play ice hockey tomorrow. That is Q. We can write it as P implies Q. Then the converse is Q implies P. It means I will, what is Q? I will play ice hockey tomorrow. Ice hockey tomorrow if it ices today. If it ices today. This is a converse. Now question number 6. What is the Cartesian product of A equal 1, 2 and B equal to AB? Cartesian product contains the ordered pair of A and B elements. Those are 1A, 1B, 2A and 2B. Coming to the seventh question. What is the cardinality? What is the cardinality of the set of odd positive integers less than 10? What are the odd positive integers? 1, 3, 5, 7 and 9. Cardinality specifies number of elements. What cardinality says? Number of elements. How many elements in the set? There are 5 elements in the eighth question. A compound proposition that is dash is called tautology. When I can call a compound proposition as a tautology, if it is always true, then it is called tautology. Ninth question. A compound proposition that is neither tautology nor contradiction. What is tautology? Always true. What is contradiction? Always false. What did the statement says? It is neither tautology nor contradiction. Then we can call it is a contingency. We call it is contingency. Question number 10. The contrapositive of P implies Q. Just now I have explained you what is converse, inverse, contrapositive. Look at if P implies Q is there, converse is Q implies P, inverse is negation P implies negation Q, and contrapositive is negation Q implies negation P. Now, what is the question? The contrapositive of the proposition. What is the contrapositive? Negation Q implies negation. And the next question, the inverse of P implies Q. What is the inverse of P implies Q? Negation P implies negation Q. And the 12th question is negation of P by conditional Q is logically equivalent to. How do you write biconditional? Biconditional, you can write it as P implies Q and Q implies P. If you write this is also true. If you go for further simplification, you can write like this. Negation of and P implies Q, you can write as negation P or Q, and Q implies P, you can write as negation Q or P, and again, if you can simplify this negation, you can write it as negation of negation P, P, R becomes and, Q becomes negation Q, this and becomes R, this negation of negation Q becomes Q, R becomes and, P becomes negation P. This is a simplified form. Among these three, even you write this one or this one or this one, anything is okay because it is said logically equivalent. It is not asked about any simplification form. Anything you write, it is correct. 13th question. The compound statement A conditional B is false. Then the truth value of A and B are respectively. So A conditional B is false when A true, B false. Here A true, B false, A implies B is false because A assumed as a true, then true implies false is false. So means this compound proposition is false when A is true and B is false. 14th question. Let Q of X means it is given a predicate Q of X be the statement X less than 5. What is the truth value of the quantifier for all X Q of X having the domain as real numbers? Because it is for the real numbers, you can say, is it that every real number is less than 5 because it is for the universal quantifier for all X? Can I say every real number is less than 5? No. Then this truth value of this predicate statement is false. Then 15th question. The statement at least one of your friends is perfect. At least one of your friends is perfect. Let P of X be X is perfect and F of X is your friend, and let the domain be all people. How do you write? So at least one proposition is mentioned. At least one means there exists X. So we can say there exists X. X should be your friend. So we can say X is your friend, F of X. If X is your friend, then means we can write implies X should be perfect. We can write P of X, right? Next question. Question number 60. Which of the following statement is a proposition? Tell me what is a proposition. Proposition is a statement. In the given context, it should have truth value true or false, but never be both. Option A, get me a glass of milkshake. It is a command. It is not a proposition. God bless you. It is just blessing. It is not a proposition. It doesn't have a true or false. What is the time now? It is a question, not a proposition to have a truth value true or false. But look, the only odd prime number is 2. But what is 2? 2 is an even prime number. But what is saying odd prime number? Then the statement is false. Means this is a statement that has a truth value false. Then I can call it as a proposition. Answer is option D. Now 17th question. Let P is a proposition. I am in Delhi. Q is a proposition. Delhi is clean. Then it is asking Q and P is. What is Q? Delhi is clean. What this says? Conjunction. And what is P? I'm in Delhi. Means Delhi is clean and I'm in Delhi. That is an option A. Then 18th question. P implies Q and P implies R is logically equivalent to. What you can write P implies Q? You can write it as negation P or Q. And how do you write P implies R? Negation P or R. Reverse of distributive law, if you apply, you can write as negation P or Q and R. Correct? So we can write as negation P or Q and negation P or R. So it is just like a negation A or B formula. What is negation A or B? Negation A or B, you can write it as A implies B. Now what is A here? P. What is B here? Q and R. So answer for this question is P implies Q and R. That is an option A. 19th question. P implies Q is logically equivalent to. It is a straightforward question. P implies Q is logically equivalent to negation P or Q. That is matching with option C. Question 20. P biconditional Q is logically equivalent to. P biconditional Q you can write as P conditional Q and Q conditional P. That is matching with option C. 21. Let P of X denote the statement X greater than 7. Which of these have truth value true? Suppose if X is 0, 0 greater than 7 is false. But question is saying that truth value should be true. If X is 4, 4 greater than 7, false. X is 6, 6 greater than 7 is false. X is 9, 9 greater than 7 is true. So answer for the question is D. Question 22. It is cloudy and drizzling now. Therefore, it is cloudy now. It is cloudy, I can call P, and drizzling now, I can call Q. This is logically implying it is cloudy, that is a P. So means P and Q is implying P. It is an implication. This implication is called simplification. These logical implications are called simplification. Simplification. Right? That is an option. The statement every comedian is funny. Here, do remember every comedian means for all. Where C of X is a comedian and F of X, X is funny, and the domain consists of all people. All people are there, but not only the comedians. It means for every x, if x is a comedian, then definitely that x should be funny, right? So we can call f of x. So what it is matching for all x? C of x implies f of x. So answer is option D. Question 24. X such that x is real number between 1 and 2. X is real number between 1 and 2. How many real numbers you can expect between 1 and 2? Infinite number. So we can call this set is infinite set. Question 25. The number of power sets of AB where A and B are distinct elements. So how many elements are there? 2. If there are n elements, the number of power sets are 2 power n. Here when n is 2, the number of power sets are 2 power 2, which is equals to 4. Question 26. X such that x is an integer neither positive nor negative. Do you have an integer which is neither positive nor negative? That is 0. It means we have a set 0. It is not empty set. I can call it is a non-empty set, and it is only one element. We can call finite set. And option D, what it says is both non-empty and finite set. Option D is most appropriate. And answer for the question is option D. Question 27. Write set 1, 5, 15, 25 in set builder form, means in the rule form. Now look at option A, x such that either x equal to 1, correct, or x equal to 5n, where n is a real number. If n is a real number, you may get between 5 and 15, there are many numbers are possible. So that it is not correct. Option B, x such that either x is 1, okay, x equal to 5n, where n is an integer. Suppose n value is 1, you can expect 5. When n value is 2, you can expect 10, but 10 is not in the set. So option B is wrong. Look for option C. X such that either x equal to 1, where x equal to 5n, where n is an odd natural number. What are the odd natural numbers? 1, 3, 5, and all. When n is 1, you will expect 5. When n is 3, you will expect 15. When n equal to 5, you will expect 25, and so on. So correct answer for the question is option C. Look at question 28. A equal, it is a set. It is given pi as an element, and this is a set pi as an element. 2 is an element. Set 2 pi is also an element. 3 is an element. The following is true. Now pi element and set pi is also an element. Both belongs to A. This is the true statement because both are belonging to set A. Now what it is saying? Set 2 belongs to A. But is A is having set 2? No. A is having element 2. A does not have set 2. Means instead of this, it could have given 2 belongs to A, then it could be correct. What it is given? It is given as 2. That 2 in parenthesis is called, the 2 is not a set in A, so it is incorrect. Pi is subset of A. And do remember, pi is subset of any set, so it is not appropriate. 3 is subset of A. So here, what is 3? 3 is an element in A. So we can say 3 belongs to A, it is correct. But we should not write 3 subset of A. So D is wrong. Question 29. Convert the set x such that x is a positive prime number which divides 72. Positive prime number which divides 72 in roster form. Now, we'll go ahead with an option. 2 can divide 72. 3 divides 72, but 5 does not divide 72. So it is wrong. Option B is directly wrong because 6 is not prime number because it is a positive prime number. And C, 2 can divide 72, 2 into 36, 72, and 3 into 24, 72. 2 and 3 are the positive prime numbers that can divide 72. So answer is option C. And option D is wrong because option D says empty set. Question 30. P and Q is logically equivalent to. So here it is given of options. We have to simplify the options and see which is correct. First option, if you see, negation of P implies negation Q can write as negation P or negation. If you apply this negation inside it using the De Morgan's law, negation of negation P is called P, R becomes and negation of negation Q becomes Q, means this statement is equivalent to P and Q. So answer for this question is option A. That's about all the 30 objective questions which is helpful for your mid exam. Hope you have understood and enjoyed the lecture. If you like the video, please do subscribe and share with your friends. Thank you. Wishing you all the best.